Okay, hi everyone. My name is Yoann.
My name is Paola.
And we're going to speak about disaster recovery testing at Booking.com. But before we do speak about that, let's make sure we are on the same page. So incidents and disasters do happen. It's not something that you may say, oh, I'll test that next year, or it's too risky. Right? It does happen. And maybe we'll start with a small game, just to make sure we're on the same page, basically. So we'll cheat. The first is from this morning, so it's not a difficult one. So we are back in October last year. Facebook and all those services are unavailable. Okay, what did happen? Is anyone thinking it's due to a CLI command running? Like anyone raising hands for that? Yeah, I see quite a few. Okay, anyone thinking this is a power issue? Quite a few more hands, a little bit less. Okay, so yeah, we had a CLI command basically, which trained all the traffic and creating an outage. I'll not give details about it because this was done this morning, but that just shows you in one. Paola, maybe another example?
Yeah, we have this example. It was public cloud, some outages in Google and Oracle early in the summer. So who think it was a network issue?
No one?
No, there's a few hands there. Warm summer? Yeah, so it happened on the 19th of July. Heat wave in the UK. Yeah, you see the red data center. Nothing more to explain here.
Okay. One last, just to make sure we're good after lunch. So we are a different topic. We're in June this year. We have a big part of Canada that completely lost internet. Things happen. Anyone thinking it's due to an animal issue? Hey, quite some, because of the picture, right? Anyone think it's a flooding issue? There's water in the picture. Oh, okay, still something. Yeah, it's basically our lovely beaver here. I just was playing with a tree. The tree fed on fiber optics, and no more internet. So why we did that right now? It's just to show you that disasters can happen for any reasons. Like you can have the best CI/CD integration you ever want. Things will happen. The only thing you can do is prepare for it. And Booking.com is not different. We had our fair share of outages, we have disasters, and we have to get prepared. And for us, the story starts in 2018, basically. So it's a lovely morning. Someone does a change. We use Puppet for configuration management. Person prepares the change, deploys it, and yeah, no more booking. The site was unavailable for many hours. It took like 10, 11 hours to restore all traffic. We had hundreds of thousands of calls to our customer service of people like, hey, I cannot book, things happen. And that's why we decided that it's time that we invest in it. So we first tried to fix that. So this was due to the traffic management layer. I don't need to go into the detail, but we just make sure that this won't happen. So we worked on more on this. Pavlos is actually well aware of that, so that's a good thing. And we tried to fix that, and that's it. But then it's one system out of so many different microservices. So we decided to take a step back, basically, and try to think, okay, what will happen if anything happened in my infra? And test it. Before that, maybe it's just a few words about our infrastructure, basically. So at Booking.com, we have around 80,000 servers, which are mainly on 3 core regions, all in Europe, in Amsterdam, in Frankfurt, and in London. And then you have a few edge regions, which are just close to the customers for basically latency reasons. And it's a bit more than 2,000 services at the moment. So it's like millions of requests coming every second into our systems. And so our test was simple, actually. We'll take one of this region, let's take Amsterdam right now, and we'll say, okay, let's evacuate traffic. Just that. A simple test for us, but our first test. We're still in 2019, we need to start somewhere. So we started to think of the problem, and the thing is, there was no way to do that. Like, if you took 10 systems, there will be 10 different ways to actually evacuate traffic. You might have a CLI command running somewhere. You might use a UI for now. You may have a bash scripts just hidden somewhere. Just different ways of doing. So we couldn't do it alone. So we had to take many, many people, a few hundred people in total in the company, and say, OK, let's get organized. We'll have a spreadsheet where everything is. Just do your stuff. Make sure things are going right. Well, that's the day we discovered that there's a limit on the amount of people that can use Google Spreadsheet at the same time, just to give you an idea of the amount of people we needed. So we did that. We evacuated traffic. It went well. We didn't have a major outage, which is a good thing for us. But at the same time, we have a few failures, like 30% of the services were not able to do it. Some people think service failed. Like, it was not an easy exercise. And we had hundreds of follow-up, like a huge amount of things to do. And there was a big risk because we technically knew we couldn't actually evacuate traffic. If we were having a real outage tomorrow, well, tomorrow from that time, we knew we couldn't survive. So we had to structure ourselves. We were just like 4 or 5 volunteers at that time. We couldn't do that alone, and that's basically when Paola comes back.
Hi, so yeah, they told me we have so much to do. I remember I interviewed, they say, hey, we did our first failover test. I was like, oh, what is a failover test? So, and we have about 100 tickets. Yeah, it was a lot. So they needed someone with project management skill set to help with the program. Yeah, we started. It was only the first step of the transformation. So yeah, there was a lot to do. First thing, get people tell us which day they can start testing their services for failover. And then at that point, I was like, okay, yeah, I need to understand this whole thing. It was my first time working in disaster recovery. I didn't know anything about it. So yeah, the first thing was like, we need to understand where we're going. So what's the objective here? I remember the first conversations, 4 or 5 people, some SREs. They was there. And yeah, they were saying, hey, if we lost a region, yeah, we should keep up and running. We cannot lose business continuity. So we have to make sure that we can actually transfer to a healthy region and not lose business. So yeah, okay, that was the objective. And from there, we started. What was the next goal? So we actually needed to increase the scope. And this is how we started. Yeah, but it was a little bit complicated because, of course, you have to make some communication. You have to actually analyze the risks. Yeah, actually doing tests. You can actually create another outage because of a test. There were investments to do. Some costs, we knew, for example, from previous postmortems that yeah, switching over databases could cause blips in transactions, for example. So yeah, it was a little bit difficult. So you don't only need to convince management, but you also need to have the buy-in of the people. And yeah, that's where conversations got a little bit complicated, difficult, with some areas that were not so close to the objective. They would think, do we really need to lose business continuity of our service because of a test? Well, this is an investment. And even people would think, some of them, like, yeah, this type of disasters wouldn't actually happen. But yeah, we saw they do happen. And yeah, the benefits were seen midway of the program. But before we go into that, I wanted to share a little bit how did we actually grow the program. So yeah, you here apply some project management techniques. You want to make clear roadmaps. You analyze your exercises. What do you want to do? You go from less risky to higher risky exercises. You make wide comms. I remember there was yeah, problems over and over with some drills that people were like, I didn't know that there was a drill happening. And it took us a bit. I started spamming people at some point. Then there is when the teams started growing, because you need more people, you have to align them. So for visibility and alignment, we introduced a wiki agenda, so everybody knew what to bring into the meeting, feedback, inputs. And yeah, risk control. Controlling risk is very important. We actually went for what we knew that would happen. What you don't know. But what we knew, we had to actually communicate, not only to the people, management. And people, yeah, you actually at some point need people from different areas. And this is how the cross-functional collaboration started. Really interesting conversations there. I was actually having fun. And I thought, okay, I'm a lady on a mission. So I want to share this flywheel, because people in the center of everything, that's the most important thing. But then there was something special. We started doing execution plans. So these execution plans were actually the core of what we wanted to do. We thought about making a hypothesis, designing an exercise. We wanted to know the goal of each exercise. Not only failovers, many things came later. We wanted to understand which steps we wanted to follow. Those steps became later repeatable playbooks. From these execution plans, we also knew which people had to be involved. We need people firefighting for an induced outage. Who do we need? Do we need comms, leads, and scribes for the execution team? But we also need other people to be there that could actually help on the firefighting. In this execution plan, we also identified deficiencies. And this is a very good part of the testing, because actually during the preparation phase is when you actually understand what the deficiencies are, and you go for analyzing what are the fixes that we need, and you improve. Some of them, most of them, actually, before even the drills were happening. Then you run the scenario, and then some things break even more, and then you know, okay, we need to go for fix. Follow-ups come, and then you go for postmortems, reports, and at some point you actually increase the risk. FISC, increase the risk, repeat over and over again, and it's basically a recurrent process. So, soon the benefits were started to be seen. This graph here is about the benefits on the automation. So it's about standardization. So Yoann was sharing at the beginning that we had basically no standard way of failing over. It was our first drill on that December. So it was about 300 people doing manual work. It took more than 4 hours for that failover. And yeah, it was a lot of manual work, a lot of spreadsheets. And then at some point, yeah, we thought, okay, we have to do standardization. And that's when we started working about on having 3-4 ways of failing over. Later on, we wanted to double the scope. So it was from a few hundred services to, yeah, more than a couple thousand services. Of course, we increased the amount of people, still manual, but that's when the first automated failover started happening. Still, around 90 services were done one click at a time, so it was still painful. And then, yeah, it was the time of thinking, now we need automation for this. So there were some scripts, and the teams were working on automatizing it. Some of the scripts later became buttons in a UI, a few buttons, also in an API. We hit February of 2021. Incident. It was in the winter. It was in Germany. It was cold, but there was still a cooling incident. First time testing the scripts. What happened? Well, air conditions froze, and there was this real outage that we needed to handle. So that's when those scripts were applied, and it was great. After that, actually, there were more work on automatizing, and yeah, here you see a screenshot of those 2-3 buttons. So we actually could do the failovers in a matter of seconds. So we passed from more than 4 hours to a matter of seconds, from 300 people and then double in the people to just one person clicking a button. Automation was, yeah, a very nice way of saving the traffic. And then those tests became fully automated. So every week there's all traffic being transferred. You want to share a little bit on that?
Well, actually, there was a talk this morning. They called it Storm, I think, at Facebook, when they try to isolate traffic on things every 30 to 45 days, if I recall. And that's exactly the same idea. So we got confident at some point we could evacuate traffic. It's not a problem for us. We did once, twice, we did many times. So we can just fully automate it. So the SREs created a tool that just does the action. You just say, how often do you want to test it? Daily, weekly, monthly, choose what you want. And then we start the failover completely automatically. We just abort everything if anything happens and just report the state. So yeah, we basically stopped doing this kind of drill because it's just daily practice. That's all it is.
So, not only benefits on tooling and standardization and automation, but the most benefit was for the people. Deployments, they are being done region by region now. People are safe. We are not losing business continuity if anything should happen. Also for changes in infrastructure. So people are more confident in doing stuff. And yeah, we avoid losing business continuity. That's a great thing. Also, very important, remember about those execution teams? So we actually were bringing people every time in a new drill, new people, and train them. It was not only about doing the exercise, but about the training of the people. People were there, and they knew how to respond. They knew the playbooks, and things got pretty easy for everyone, and there were more and more people. And the behavioral change. This is, yeah, like the highlight here. What happened there was we started seeing that some people were prioritizing already work for the next drill, proactively, which is great. At the beginning, it was very difficult communicating. Now people were prioritizing work because there was a drill coming, and they knew about it. And there were other people also saying, oh, yeah, we want to do a drill as well. They were approaching the team for comms and visibility. That was great. But what's next? Yeah, we talked about there were other stuff, not only failovers. Yoann, for you.
Well, I think it's time to take a step back, right? We spoke about failover for some minutes here, but the thing is, okay, is it enough? So we took a step back, basically, and look at it. Okay, that's just the text. For our talk, disaster recovery testing, that's what we wanted to do. Disaster recovery. There's one thing interesting here. So recovery. We technically had no outages when we did the test. Like, there was nothing really to recover from. We just moved traffic away, put it back, but like nothing really happened. If we were in a real situation, we could think as what would be? We mitigated maybe an incident. What would? Let's say we were doing like disaster mitigation testing. It's basically what we're doing. But disaster. If there was no incident, there was no disaster. So mitigation would work if a product went down, if a business features went down. Sorry, many things would be okay. But what would happen if there was a real disaster? Would our failover mechanism work or that? We have no clue. So we kind of did small incident mitigation testing, technically speaking. Like no disaster, no recovery, nothing. Just evacuation. This is very useful, but that's all we did. So from that time, we decided to think, okay, what could really happen? We could lose power. I mean, we could lose a feed. We could lose a generator. We could be forced to power down. That happened when it got hot. You mentioned the Frankfurt incident. So things can happen. The network also, it's good most of the time, but we could start having extra latency between regions, between data centers. We could have a network issue that isolates things completely. Things can happen. So it's time to test it. So that's our first test. We come back with our 3 regions, Amsterdam, London, and Frankfurt, and we decided to see, okay, what's going to happen if there is a disaster in between London and Amsterdam that strongly impact our network? For us, there was 3 different kind of scenarios. We played with dropping packets randomly. We played with adding latency on purpose. We played with fully cutting the network. And it's not that difficult to do. I mean, we had to rent a piece of hardware, put it in the data center, and add people operating it. But it's largely doable. Every one of you can do it. In terms of risk, so we knew how to fail over. So if something happened, we could evacuate. That's one thing. Like, you have 3 regions, right? If you evacuate Amsterdam in that example, the issue is invisible. So we could mitigate that. Also, there was always connectivity between the 3 data centers, so it's all fine. The risk is under control. So let's get the buy-in, as you mentioned, and let's play this test. And in terms of learnings, we mainly had 3 things. The first one is that we heavily relied on some primary, secondary kind of systems. You can think of databases, for example. Like, if I'm in Amsterdam and I need to speak to a primary node in London or something like this, and it gets slower and slower, that might get complicated. We use Kafka heavily also. Like, if your partition leader is in London and you're in Amsterdam, you'll have exactly the same issue. Like, It's something we saw a lot. So we saw that in the preparation phase. We mitigated most of the impact. And that was fine, but there was some work there. But then again, data replication started to be an issue. So we don't use primaries too much and things like this, but you still have a delay now between Amsterdam and London. And we had a few systems that always thought that we use MySQL a lot, every MySQL replica was always up to date, like to the milliseconds. Well, that's not possible. And when something happens, that's far from being true. So we are going to adjust a few systems. OK, what happens if there's a delay? People do that in the preparation phase and things like this. Well, on the day of the drill, we had another one, but it's timeouts. I mean, it's good, right? It's just to make sure they don't hang. It's what we need in most queries. But if your timeouts are too tight and you start to have latency between two regions, it starts to be a problem. Like we had a lot of automation that started to behave in a way that we would never predict before. But that was the only major issue in that scenario. So we got confident, like, it's good, it works. If that happens, we're good. Let's continue, let's get stronger. What about we fully isolate one region? So I took Amsterdam in every example because that's in the middle for you, but obviously we change things. So we take Amsterdam here and we say, OK, you cannot speak to Frankfurt or London. You cannot speak to the internet like you're fully isolated. In terms of difficulty, that's simple. We just played with firewall rules, and the system was isolated entirely. That's simple to do. In terms of risk, though, it's a bit more risky than the previous setup, because you could think of sprint brain scenarios and things like this. But still, like you could just reopen the firewall rules, mitigate in a minute. Failover, like it's not that risky, right, Paola? It's a simple thing.
That's the day we lost the VPN.
What thing can happen? On the day of drill, we just lost our VPN. And that would be OK if it was not COVID. So obviously,
it was COVID.
Obviously, everyone was at home. And we had to fix that issue. And that's actually one of the big learnings. So when you test your systems all the time in standard conditions, and you see it working, it doesn't mean that it will work when you have a real outage. So it was a good thing. We learned something, we fixed it, and today we can test that again. We know it's going to be good, at least for the VPN. But then we had other things which were interesting. One was health check. So we have quite a few systems which were using health check in a push model. So you would have a daemon or a sidecar running close to you, say, hey, how are you? You good? OK. And I will actually speak upstream and say, hey, this person or this system is actually doing well. But now think about it. If I'm in Amsterdam, I have my sidecar, and it says, hey, you're not doing well. OK, I'll say that you're not doing well. But I'm trying to speak to Frankfurt. Frankfurt will never be aware that my system is unavailable. It will just not do that. So there will be a delay of, depending on the system, several seconds or several minutes in which Frankfurt and London thinks everything is fine in Amsterdam, while the system is completely unavailable. So we had to push a bit many systems to mostly poll the health of the system and say, hey, how is it going across regions? And the last thing is MySQL group replication. So I already said we use MySQL quite heavily. And we already discussed group replication before. So that's a way to have a kind of a multi-master setup. But we never invested in making it in production. We just had the idea. We wanted to do it, but there was no prioritization on doing that. But if you take this scenario, you clearly understand that you will not survive without something like this. So if your primary is in Amsterdam, Amsterdam will say, hey, I'm good. The primary is alive. The replicas are alive. Everything is good. But then you're in London and say, hey, there's no primary. OK, automation kicks in, pops a new primary, and you get a split brain situation. So we started to test that during those kind of drills. We first did a few chains only, opened the firewall rules for the others, because, yeah, it took some time to put everything, and we're still not there. But then it works. So we did the drill, and nothing happened, except the VPN went. We fixed the VPN, then nothing happened. Maybe one more and one last scenario. What about if we lose power? I mean, that can happen. That happened in the Frankfurt situation, for example, when we had to power down everything. What happened there? In terms of difficulty, I mean, that's the simplest thing to do. I mean, my son is doing it by accident many times. You just pull the plug. Like, it's a very simple situation. In terms of risk, though, it's not that easy. OK, you could evacuate stuff. OK. But as we said before, what about the recovery? How I put back things? And in that case, there is no abort. If you power down a full data center or a full region, you have to put it back on before you can use it. So we do preparation, we look at it, and we run it. That's the only way to go. And basically, it triggers, again, some question. During preparation again, what about any secure dependency that would happen? Like if you evacuate traffic, put it back, nothing changes. It's quite OK. But when you have to restart everything, it can be a challenge. So I kept a question mark here because we've seen a data center being down, and that was OK for us. But what about a region going down? What about more systems going? Like, we're not fully sure, but that was good learning there. The other one is managing power again. So it's like 80,000 servers at Booking. If you split it half, that's like 25, 30 per region. So if you have to pour up everything at the same time, it's not going to go right. You're likely to have an issue. So we have to learn how to start things in a batch process. Start by that service, which we know is at the end of the stack. Make sure your data stores are back, make sure everything's back, and we knew how to restart things one by one. But then the last thing was the restore time. So we always know the stateless versus stateful thing, and OK, it makes sense. So I can restore any stateless service in a second. That's fine. But when it contains data, that's where it's interesting, for many things for us. One is we never actually have metadata about it. Which service contains data? Which data? Is it up to date? Like, it was something tricky to get. Another thing is the duration of a test. So if you do a test for 5 minutes, yeah, most of the data will be OK. We'll catch up quickly in most cases. It's fine. If you're out for hours, it might not be the same issue. Some system, for example, will have to completely restart from snapshots after a certain amount of time. So it can move from seconds to minutes to hours. So that's all the things that we've learned all during the preparation phase and things like this. The funny part with this thing is we never actually run the drill because it happened in production. But we got the learnings. We were ready. It just happened in production 2 weeks before we wanted to test it. So that's a good thing. But more scenarios, so you can really think about what is closer to you. All of that still remains true if you're using public cloud, like you had the Google and Oracle incident, for example, where the region wasn't available. Things happen. So you can think about it, test your system, and see how it goes. But that's theoretical, right? We were having full control about the test. We knew how to abort, how to revert. What will happen in real life? Like in 2018, it was quite bad.
Well, that was the one that he was talking about before, and he got my line. So yeah, 19th of July, it happened. So we were preparing everything. We did all the scenario design. We had trained the people. We had the playbooks. All of those techniques that we were talking about. The important thing was that people knew what to do. And actually, before doing the test, it happened in production. So air conditioning was not working, temperature were rising, and then what happened? Everybody got on the call, everybody knew what to do, they started taking traffic away, things were cooling down already, and then, yeah, they started putting things back. So that's when you get, when you train your people, and you can actually sustain real outages in a graciously way. So, some key takeaways. So, 90% of the learnings come while you are preparing, actually, the drill. Design the drill and train people. Remember about the VPN thing? So, it's all about managing risks. So, learn and prepare beforehand. Train the people, rotate them, let them play with stuff, break stuff, and test for disasters. So when you actually test the real disaster or simulate a real disaster is when you are actually prepared for when the disaster really comes. So prepare your people for disasters. That's the one idea. We hope to encourage people here. If you're thinking about it, this is the story of having nothing to having something that is working. And thank you, everyone, for listening.